Om Prakash Samantrai, Assistant Professor in CSC. We are discussing Database Management System. In this video, we'll discuss Dbms storage system and different file organization techniques used in Dbms. The database contains the data and the data are stored in the form of files. The file contains a number of records. At the physical level, the actual data is stored in some storage device or the memory. The storage devices are broadly categorized into different types like primary storage, secondary storage, and tertiary storage. The primary storage are usually those memory devices or those storage devices which are directly accessible by the processor, which are closely coupled with the processor. Usually, the registers, cache memory, random access memory, these are known as your primary storage. The size of these primary storage are usually small, but access speed is very high, and these are volatile in nature. That is, once you switch off the power, the data stored here are lost. Similarly, another kind of storage device is your secondary storage, which is larger in size as compared to the primary storage, but smaller in speed as compared to the primary storage. That is, the speed of this secondary storage is less as compared to the primary storage. So that is, it takes more time to access the secondary storage because these are not close to the processor. So all the memory devices which are not the part of the CPU chipset or the motherboard comes under this category. Magnetic disks, optical disks, DVDs, CDs, flash drives, magnetic tapes, which are not directly accessible by the CPU. This comes under the secondary storage. Usually hard disks which contains the OS and generally not removed from the computers are the secondary storage devices. And these are non-volatile in nature. That is, the data stored here are permanently available in the memory, permanently stored in the memory. Even if you switch off the power, the data are retained in the memory, and whenever you switch on the computer next time, you can access the data. That is a non-volatile storage. Tertiary storage means the, you can say, these are the external storage devices. These are external to the computer system, hence they are slowest in speed. The size of these tertiary storage may be big, but the speed is very less. These storage devices are usually used to back up the entire system so that in case of recovery, in case of failure, when you want to recover your database, you can uh, get the database from these tertiary storage. Magnetic tapes, optical disks are widely used storage devices as tertiary storage. Right. So these are the different types of storage structures. How the files or file records are mapped into disk blocks, what we call that as a file organization. The method of mapping the file records to the disk blocks is called as the file organization. That is how the files and records of the files are organized in the memory. Different types of file organizations are there, like heap file organization, hash file organization, sequential organization, index sequential file organization. So in the heap file organization, usually the operating system allocates a memory area to the file without any accounting details. That is, the file records can be placed randomly in the memory, and the operating system do not keep track of that place where the records are being placed. Right, and it is the responsibility of the software to manage the records. A heap file does not support any ordering, sequencing, indexing on its own. Sequential file organization means, you can see, sequential file organization means every file record which are stored sequentially based on a particular attribute, and the attribute must be a unique key field, or you can call it as a search key, and based on that value the records are stored sequentially, right? For this, the key or attribute must be a unique attribute. It should not contain duplicate values. So what are the advantages of sequential? It is good for batch transactions. It is very simple to implement. It is good for report generation and statistical computation, right? And the disadvantages are, it is not good for interactive transactions, and increases the overhead while executing the queries, right? That's why index sequential file organization, and it's a better approach where indexing technique is used. So this indexing technique, along with this sequential file organization, it reduces the access time. It may not reduce the storage requirements because a new concept index is used here. It will take some memory space, but with help of that, the access to the database will be faster, right? So index concept is similar to the index concept used in your books. You can see at the end of the book there is index of terms, and using those index of terms you can directly go to the page where the particular word is explained. Similarly, based on a particular property, based on a particular attribute, all the records of the file are um, stored in the disk. Either it is in a sequentially, if the records are stored in sequential manner, and based on the particular attribute, one index file is created. That index file will contain the value of that attribute and pointer to the record which contains the value of that attribute. So a separate index table is maintained which has only two columns. One is the index attribute value and the corresponding pointer, right? Advantage is efficient file system for medium and large sized files, easy to update, easy to maintain, efficient usage of storage. Searching of record is fast. This is the very important point. Searching becomes very fast, but if you implement the indexing for smaller sized files, then it may increase the overhead. It become inefficient, and generally it is an expensive method in terms of space. Similarly, hashed file organization. In the hash file organization, you use a hash function, and based on the result of the hash function, the records are stored on some block of the disk space allocated to it. We call that as a hash table actually, and using the hash functions result, we store the key in the hash table. Usually there are so many different hash functions are used, and division method is the most popular hash function method, using which we store the keys in the hash table. Insertion of new record is fast and efficient. The filling factor of this file organization is 100% because in all the locations the keys can be placed. That's why the filling factor is 100%. Space is fully utilized and conserved, and different collision resolution techniques are also used if collision occurs. Collision means when multiple keys are placed in the same location, we call that as a collision. And different collision resolution techniques are used uh, to correct or to get rid of that collision. That's why you can say the filling factor is 100% here. Deletion of many records result in wastage of space. This is the disadvantage of this hash file organization. Now, index file organization. As I have already told you, in the index file organization, indexing technique is used. The indexing is done based on a particular attribute. We call that as indexing attribute. Indexing can be done on these following, or the different types of indexings are there: a single level ordered index, multi-level index, and dynamic multi-level indexings. The single level ordered indexing, it can be applied on a primary index, it can be a clustered index, it can be a secondary index. When the indexing is applied on multiple levels, it is called as multi-level indexing. Or using the B tree and B plus tree data structures, we can also implement that multi-level indexings dynamically. And the indexing can also be done on multiple key attributes. So, and another thing is the ordering field, or the ordering attribute on which the records or files are ordered, uh, can be used to create an index on that, or on that ordered field. In that case, we call that as uh, you can say ordered indexing, right? It can be different from primary or candidate key of a file. So the ordering field is not necessarily a primary key or candidate key. It can be any key value or any field of your database, any field of your table. Ordered indexing can be of two types: dense indexing and sparse indexing. In the dense indexing, you have many pointers. The sparse indexing, only you have less number of pointers. You will come to know the difference here. You can say primary indexing, right? If the index is built on ordering key field of the file, it is called as a primary indexing. So usually when the indexing is done on the primary key, we can call that as a primary indexing. It is not necessarily primary key, it can be created on any of the key fields based on which the records are ordered. Okay, the data file is ordered on the key field. Generally it is the primary key of the relation. This file contains the index records which are of fixed length. So each index record has two fields. One is your primary key of the data, another is your pointer. You can see in this diagram, if this is your original table, this is your original table, employee table. Assume that name is a primary key here. You see the right side of this image, name is the primary key. Here name is taken as a primary key. Actually name should not be the primary key, because two employees can have the same name. But assume that name is a primary key here, and based on the name the records are ordered here, and all these records are placed on disk blocks, you can say. Each of these boxes are known as your blocks. Now this left hand side, this is called as your index file, which is two columns. One is your primary key value, another is your block pointer. That is, here Aaron is the value of the first field, or first value of the block, and against that you get a block pointer. Similarly, Adams is the first value of the second block, against which you get a block pointer. That is, the value of the first value of each block are stored in the index file, and the corresponding address is also stored in the index file. This is called as your block anchor. Block anchor, the first value of each block is called as your block anchor, and the corresponding pointer is also stored in the index file. So this is one example of your sparse indexing, because in our non-dense indexing, here instead of having a pointer to every value in the block, this indexing technique uses only one pointer to each block, so that if you want to search for this value marrow, the last value of the first block, then you can directly go to, you can search from Aaron in the index file. Then next value is Adams. You are searching for some X ACC is the initial letters of the name, so it must fall within this range. That's why you go to the first block, and in the first block you have to search the requested key value. So it's easy to access the value when you use the index file. So this is example of your sparse indexing. If if you maintain an index file which contains all the values of the primary key field here, and instead of having a pointer to each block, if you maintain a pointer to every value of the primary key, then that is called as a dense indexing. So dense indexing takes more space, right? Secondary indexing, you can see secondary indexing is built on non-ordering field. The previous case, the primary indexing was built on ordering field. It is built on the non-ordering field of the file, then it is called as a secondary indexing. So it provides a secondary means of accessing a file for which some primary access is already present. The secondary index may be on the field which is a candidate key or has a unique value in every record, or it is a non-key with duplicate value. So secondary index can be applied on any of these keys because it is a non-ordering field. Okay, it is not necessary that on that key the records are ordered. So it can be applied on a secondary key or any of the non-key attribute of that file. The index is an ordered file with two fields. You know that two fields are there in the index file. So in this case, the first column will have the key value, the non-ordering field on which you are constructing the indexing or index file need to be stored here, right? And here the index is the ordered file. This is the ordered file. This is not the ordered file. Now this is the ordered file. The index file is the ordered file here, but the value of that attribute on which the index file is created need not be a sorted one. That is the original memory. The value may not be sorted. Records are not sorted according to the field here, but the index file is sorted. You can see here 9 5 13 8. This is not sorted here, but in this case this index file, the index field value is sorted here 1 2 3 4 5 6 7 8, and the corresponding block pointers are used in the index file, right? So this is called as your secondary indexing technique. Clustered index, if index is built on the ordering non-key field of the file, it is called as a clustered index. So defined on the ordered data file, clustered index is also defined on the ordered data file in which the records are ordered on a particular key attribute. Data file is ordered on a non-key field, like unlike primary key, which requires that the ordering field of the data file have a distinct value for each record. It includes one index entry for each distinct value of the field. The index entry points to the first data block that contains the records with data field value. It is another example of a non-dense index where insertion deletion is relatively straightforward with a clustered index. Right. So you can see this example here, clustering field value Here this is a sorted one, right? You can see based on the department number, you can see all the department numbers are clustered here. One are clustered here, two department number two are clustered here, three are clustered here. In case of three, you can see there are so many employees who belong to department three. That's why there are multiple blocks here, and each block are linked to each other. So based on the department number, these records are clustered here, and then these are sorted in the index file. And whenever the value of that field is 1, the corresponding pointer is used to reach that block. So again block pointer is used here, right? So it's similar to your primary indexing, but here a non-key attribute is used, and because of the non-key attribute duplicate values may be there, hence the values are clustered here. And now the clustered blocks are kept together, and the corresponding value are used in the index file. So this is your clustered index, right? So in the multi-level indexing, so far we have seen that original data file, and we have seen only one index file. That is index file is used in only at one level, that is a single level indexing. But in multi-level indexing, the indexing file is created in multiple levels. That is, when the size of the data file becomes more, the size of the index file will also be more. And sometimes the primary storage is not sufficient to hold the size of the index file. In that case, the index file is further divided into blocks, and another index file is created for the index file itself, right? So the index files are organized in separate levels, multiple levels. So this is an example of a two-level indexing. This is a data field. You can say the first level, the middle one is your first level indexing. So for this data file, these are the first level indexing. Again, for the first level indexing, you have a second level indexing. So your the second level indexing will be there in the primary memory, right? So to reduce the size of the indexing file, we are using the indexing at multiple levels. So this is called as your multi-level indexing, right? So in the next class, we'll discuss other multi-level indexing implementation using B tree and B plus tree. So in this video, we discussed different storage of Dbms, storage system of Dbms, then file organizations like heap file organization, sequential file organization, index sequential file organization, and index file organization. Details of index file organization like primary, secondary, clustering, and multi-level indexing techniques are discussed in this video. In the next video, we'll discuss B tree and B plus tree. Thank you very much.